I'd like to welcome you to our March pecan topics. And I wanted to start off with saying that we had a little difficulty with our recording this month. And so we're re-recording some of the topics for you so that you can still get the information. I'll go ahead and share my screen for you and go over some of our information. My name is Becky Carroll. I'm the Associate Extension Specialist for Fruits and Pecans in the Horticulture Department at Oklahoma State University. And I wanted to just go over a little bit of information about what growers might be needing to think about during their management during March. This fact sheet that we have, HLA 6200, it's a calendar for pecan growers. We've been going through this fact sheet since last May, and so we'll continue to talk about some of these timely subjects that are coming up for our growers. So some of the things that they need to be considering is doing graft maintenance, looking at those grafts they made last year and pruning them down to have a central leader structure. Maybe that may be a thing they need to emphasize in their pruning right now, but also any other type of pruning to get that central leader structure set is going to be beneficial to our trees to make them stronger and more able to withstand some of our management and some of the weather problems that they might see in the future. We want to prepare for some pests, insect pests, like phylloxera, and Dr. Phil Mulder, he talked about that this month. We'll go ahead and have that topic today. And then some other things are servicing and repairing your equipment, especially your sprayer. You want to get that out and make sure that everything is working in tip-top condition. And so you'll be ready for those first sprays that are coming up pretty soon. And so calibration is something that's very important for both your herbicide sprayers and your air blast sprayers. And we'll have Dr. John Long talk about that in just a little bit. He has a really great presentation on calibration. You need to think about merchandising, getting the rest of your products sold or stored properly. Think about where those pecans are going to be going. You can still continue to plant bare root pecan trees at this time of the season. And usually we think about mid-February into March, and even to the end of March is when you can continue to plant those bare root trees. We'd like to have them in the ground before they start to break bud. And that's kind of a time frame that we like to complete that process. Container trees can be planted a little bit different time frame, and we talked a little bit about that last fall. Also, fertilizer application is something that's important for our established trees, and then for our trees that we're planting this season, we're not going to worry about that fertilization until they're in the ground, they start growing, and then we'll apply the fertilizer at that time. All right, so you may remember that February 16th, we had a very, very cold spell, and every mesonet site on the map was below zero. So this was a freak weather event. We don't see this very often when everyone is under zero, and it was for an extended period of time that we were below freezing temperatures. So in the Pecans Stillwater area, we got to -14, -15, but there were areas just to our north that got down to -20, and over in Creek County, they were -20, but it even got down in the Idabel Broken Bow area, they got down to -5, -9. So it's very, very cold in a lot of different areas of our state. Now, how's that going to affect our pecan trees? Hopefully, it's not going to have too many negative events or consequences of those cold temperatures. The positive was that the buds were fully dormant at that time. So that is when they are the most cold hardy. So that's a positive, a plus. Now, we don't know if we're going to see any damage to wood or to buds, but we're going to have to just watch and see how they break and develop those new shoots for this next month. We'll expect maybe those trees to see some damage would be those that were overcropped last fall. If they have a big crop load, they go into the winter less hardy, so they can have more potential winter injury. And also those trees that were newly grafted, had really vigorous growing wood, or that were new trees and growing very vigorously, they may see some damage to wood tissue. Or even some more of the cold sensitive cultivars that are planted. Normally we think of planted in the northern half of the state, but anywhere in the state, they may be seeing some injury for those less hardy cultivars. But we're just kind of in a wait and see pattern to see how those trees actually do bud out, and hopefully they'll fruit this season. I wanted to mention that the 2021 pecan management class has started back. It looks a little bit different this season. We're socially distancing, we're wearing masks, and being very cautious, but we are having in-person classes. The 2020 class was canceled after their first meeting last year. So those people that were in the 2020 class had the option to go ahead and move into the 2021 class. Now, it's too late to join this year, and we're trying to keep the class size small so we can have plenty of space for everyone. But if someone's interested in joining the 2022 class, if they can contact me, we will get them on a list, and it will be the earliest people will get first preference to next year's class. I already have about a dozen people wanting to be in next year's class. So if it fills up too soon, it may be difficult to get in there. But this class, we have 21 people registered and attending. So that's exciting and a nice size for learning and being able to do some hands-on activities. We do have a homeowner pecan Zoom program that was offered by our Washington County Extension educator, Katie Hughes. And so March 25th from 5:30 to 8 p.m. And it's from the Washington County Extension Office. So if people were interested in signing up, they need to register with Katie, and they have limited space if you want to come to the Zoom class, but if you would like to join from other location, that would be open. Dr. Phil and I will talk about landscape pecans, and so a little bit different than the normal commercial type of production. It'll be more of a landscape production and how to manage those trees. This is really exciting for our pecan growers. We're going to have the Oklahoma Pecan Growers Association, their annual convention and trade show. I believe it's going to be their 90th convention. And so we had to cancel last June due to COVID, but we're going to have an in-person annual meeting and trade show in Broken Arrow at the Stony Creek Convention Center on June 10th through the 12th. And so for more information, you can register online at www.okpecangrowers.com. There's going to be more information available there. It will have an agenda, a little bit more information. The 3-day event on Thursday, the first day, we will have kind of a mini pecan course starting after lunch. That evening we'll have a social, and then on Friday we'll have our educational meeting. We will have the pecan food show. So if you like to bake, or you know someone who's a great cook that includes pecans, have them register to come. And then we'll be displaying the nut show. We'll have lots of vendors there. And that evening we'll have a banquet. And then on Saturday, we'll have a field day at a local pecan orchard. We'll have educational information. We'll have equipment demonstration and wind up that Saturday with a lunch. So it's a good meeting. It's great for networking. It's a family type of meeting. So lots of kids and families that come. And the Stony Creek Conference Center is a really nice venue. So I just wanted to mention our next few monthly Zooms will be April 9th, May 7th, and June 4th. So remember that you need to register for each month to attend. And been really excited about our amount of people that have joined each month, or those that have watched the recordings. And so that's been really great. Our next speaker will be Dr. Charles Rohla with the Noble Research Institute, and he's going to be talking about fertilization and how to apply fertilizers for our pecan trees, both for young trees and for mature trees. And so I'll turn that over to him now.
Well, good afternoon. I am Charles Rohla with the Noble Research Institute, and this afternoon I'm going to visit with you about nutrient management. So if you have young trees, you're going to manage those a lot different than you will mature trees. If your trees are just 1 year old, I generally will start off with about a half a pound of complete fertilizer like triple 13 or triple 19 or 10 20 10, anything like that at bud break. Or after bud break, after those trees have started to grow. And then you can apply about a quarter of a pound, about 2-week intervals if that tree continues to grow well. But I really like to wait until that tree has somewhere between 6 to 8 inches of growth before I start applying any fertilizers, because I'm really wanting to focus on reestablishing that root system. And so those trees can grow better than if you put on nitrogen source fertilizer too early. You're going to push a lot of top growth, and that tree's not going to focus on the root growth like you need it to. Make sure that you're applying your zinc fertilizer if you need it. And if you're applying zinc fertilizer, if you're using zinc sulfate, it's 2 pounds per 100 gallons beginning at bud break, and that's the most critical time to get started, and do that every 2 weeks up and through up until about June or July, into June or early July. You want to stop that so those trees start shutting down for the winter, so you don't have winter damage on those trees. So make sure you're not applying zinc too late in the season, or you will encourage additional growth on the trees, and you can see some winter damage from that. As your trees age into that second year, just increase the amount you're applying, and you can go 3/4 of a pound, maybe up to a pound if they're growing really well right before bud break, so that tree is able to take it up as that tree starts to break bud. And then if they're growing really well, you can do another half a pound per tree in 2-week intervals for a total of 4 applications. Really wanting to stop kind of in that middle of that June time. If you're farther north, you might want to cut it back a little, stop a little sooner than that. And then continue your zinc spray as you did the first year. Year 3, just increase that a little bit more to 1 pound per tree and make sure you put it on before bud break. That way the tree's able to take it up. And then again, you can increase the amounts you're putting out on 2-week intervals after that to about a half a pound. I really like including on these young trees a phosphorus fertilizer or something with phosphorus because that really stimulates the root growth. If you are in soils that have a lot of phosphorus availability, you can actually go back to just a nitrogen source. But I've seen some results where phosphorus really helps that tree get established in these first couple of years. During that 3rd year, make sure to go ahead and take your leaf samples. And we're going to use that leaf sample that you collect in the 3rd year to determine how to fertilize the trees, broadcasting it out on the orchard floor, because your root system should be larger. And we can use this to determine how much fertilizer to apply that 4th year, as those trees hopefully will start into production pretty soon. On mature trees, if you've got just a few trees that you're fertilizing, or not a large acreage, a general rule of thumb is about 1 pound of a nitrogen source fertilizer like urea 4600 or ammonium nitrate 3400 per inch of trunk diameter. Make sure you're measuring the trees at 4.5 feet above the soil line. to determine that trunk diameter. And so say if you've got a 20-inch tree at that height in diameter, then you're going to apply 20 pounds of fertilizer per tree. And there's really no reason to go more than 25 pounds per tree as you're fertilizing. If you know that your soils are low in phosphorus or potassium, you can use a complete fertilizer under those trees at the same rate. But it's always like to encourage people, even with small acreage or just a few trees, to pull soil or a leaf sample to help you determine if that tree needs that phosphorus or potassium. There's no reason to spend money on it if you don't need it. As I mentioned, with pecans, we typically will take a leaf sample in July. That helps us determine the nutrient values or nutrient requirements for the tree the following year. It's just like taking a soil sample to help determine what your grass needs. There's just not real good correlation between the soil sample and what the tree actually is able to take up. So the best way to determine what the tree needs is by taking that leaf sample in July. And we'll talk a lot more about that as July gets around and show you how to take that properly. Typically in our area, nitrogen, phosphorus, potassium, and zinc are our limiting source nutrients. And so that's really what we're looking at whenever we look at these leaf samples. And typically these are the 4 things that we have to apply or may have to apply. Every once in a while, we'll see something a little bit different. And if you have that, you can talk to one of the specialists about how to correct that problem. So if you take a leaf sample and if you've to fertilize, nitrogen's usually the main thing that we're considering fertilizing with. If you're in native trees or low input trees, this leaf sample will tell you what the concentration is in the leaves and then help you determine how to fertilize. So if you've got a leaf sample that come back, say 2.4, well, you're in optimal range for a native or low input orchard. So you'd continue on what you applied the previous year, or if you don't know what was applied or you didn't apply anything, then you can go ahead and put on about 100 pounds of nitrogen per acre or 150 pounds per acre. If you come back and it's a 2.75, that means that you have a lot of nitrogen in the trees. So you can actually, with these leaf samples, decrease your application by 50%. And this is a way you can use these leaf samples to save you a lot of money if you're fertilizing quite a bit of acres, if your leaf concentrations are high. And this also helps slow the tree up and focus more on nut production and less on the tree growth. If you're a high input orchard that's irrigated, you're really pushing these trees, trying to get the most production out of them, the concentrations are going to be a little bit higher. You can see the optimal for a high input orchard is going to be 2.4 to 2.7. And again, you can use this to kind of judge on how to apply your fertilizers based on what that tree took up the previous year. One thing to know about nitrogen applications, it's great. The tree's greatest demand is about 3 weeks after bud break, and then again in late gel stage. Whenever you apply that nitrogen onto the soil, it's got to be taken up through the soil and it's converted. And so, and then it has to be converted so the tree is able to take up that nitrogen. And so you want to get it out ideally before bud break, and that way it has time to be taken up into the soil and able for the tree to take it up. If you're using urea, which is the most common form of nitrogen that we see here in this region, a couple things to think about. The urea can volatilize, especially if you're applying it when temperatures are greater than 70 degrees, and if your soils are moist or high in pH. Another thing you want to think about, ideally, we want to get it out right before a rain. It takes about a 1/4 inch of rain to incorporate it into the soil, or if you have irrigation, sprinkler irrigation, where you can apply irrigation right after you fertilize, that really helps get it incorporated and you don't have as much loss on urea. If you're in a sandy soil or a soil that is prone to flooding, you might think about doing a split application. This just helps make sure that you don't lose your money that you're spending on that fertilizer through leaching or through runoff. Usually you'll do this pre-bud break and then again in late May, or perhaps you can do it pre-bud break, depending on your soil or your site, pre-bud break up through kind of the middle of May, and then again late water stage. And that way you're hitting those two critical points where the tree needs the nitrogen the most. You can use a ground cover. There's been a lot of studies that shows that legumes can replace the nitrogen needs, especially in native or low input orchards. If you have a solid or a good stand of clover under the trees. If you have non-legumes, applying it pre-break appears to flavor the trees because the tree's able to take it up before that green grass starts to grow and can take it up. So we're trying to fertilize early before the grass really starts to green up, and that just helps the tree take up more of it and less of it available to the grass. If you have herbicide strips, it's always best to try to apply most of your fertilizer in that herbicide strip, and that way there is no competition, and that tree can take it up. If you do have a drip system or micro sprinkler system, you can inject liquid nitrogen through your system. This helps minimize nitrogen loss. It's a lot more flexible for you to put it out whenever you need. You can even put it out whenever the soils are a little bit wetter. And it's a little bit more economical to do this in multiple applications. And it can help reduce your nitrogen cost by about 50% without losing any of your tree performance. Whenever you're talking about nitrogen, some things that we need to think about with pecan trees is they are terrible at taking up, have terrible efficiencies at taking up nitrogen. A lot of studies have shown what we apply, only about 19 to 27% of that is taken up through the tree. So applying nitrogen or applied nitrogen is rapidly absorbed and transported directly to storage units in the tree. And that is where the nitrogen that is used this year is directly coming from stored pools in the tree, not from what you're applying this year. So about 93% of what the tree takes up goes straight into storage this year and is used the following year. And that's why it's so important to have a regular annual fertilization program to make sure that you're promoting that nitrogen storage pools. Because the pecans depend primarily on that stored nitrogen to meet its demand, trees are readily insensitive to the timing of your application. So we don't have to make sure we put it on right before bud break. It can be a little bit after. As long as there's stored nitrogen in that tree is able to use it. But you do want to make sure you have an annual program, so you're applying annually because that tree is using it the following year. If you take a leaf sample and it shows that you are deficient in phosphorus or potassium, we have ranges for both of those, and they are different for native or low input orchards versus a high input orchard. But what we're going to recommend is that you band that phosphorus or potassium. Typically, it's between 100 to 150 pounds of phosphorus per acre in that band. And if you have drip irrigation, you want to put that right on top of your drip line. If you don't have irrigation or sprinkler irrigation, just put it underneath between halfway in between the canopy or the trunk and the canopy, outside of the canopy, and that way that tree can take it up. And we've seen through research this is a more efficient way for that tree to take it up than broadcasting it across the entire orchard floor. Here's the ranges for potassium. And same thing goes with potassium. If you're deficient in potassium, we'd encourage you to put it out in a band, again, 100 pounds to 150 pounds of potassium per acre. And if you're really high in nitrogen, you really want to pay close attention, because you can have an imbalance between nitrogen, phosphorus, or nitrogen, potassium, and you get leaf scorch like these pictures are showing, where those leaves really dry up and scorch. And it looks like a disease maybe, but it's all actually just an imbalance of nitrogen to potassium or nitrogen to phosphorus. So if you have a high nitrogen, you might want to go a little bit higher on your phosphorus or potassium and potassium to make sure that you don't have a scorch problem like you're seeing on these pictures. Here's just some pictures of ways growers have modified spreaders to put out a band. You can see here, if you just go down to the co-op store and you get a fertilizer applicator, and usually they have a spinner on the back. You can pull a pin and drop that spinner off, or if it's PTO driven, just don't turn on the PTO on that spinner. And so it's just dropping out the back. If you've got your own spreader, you might make a chute like the bottom picture, where it's just dropping off out the back, and you see the spinner's been removed off of this one, and it's just going onto a tray that's dropping it down, putting it in a band. And the picture up on the top right is out in Georgia, where they do a lot of this. And so the custom applicators have developed a chute and can put it out in that band. And you can see in this bottom picture, where you put that band out, it's going to stay greener, and you'll be able to tell where you put it. And so if you have to put it the following year, you want to put it right back in that exact same spot. If you're doing just a few trees, you can do the same thing by just spreading it out in a band like this. You don't have to do it on both sides of the tree. We've seen through research, you can just put it on one side and that's sufficient, but you can individually band per tree. Zinc is usually one of the, especially if you're in southern Oklahoma or North Texas, we see a lot of deficiencies in zinc. And so you want to make sure that your zinc concentration in your leaves are greater than 60 parts per million. If you have mature trees, usually 3 applications of a zinc sulfate at 3 to 6 pounds per acre will help take care of that deficiency. If ideally you want to put that on just as those first leaves are unfolding, and then you can put it on again with a case bearer spray and maybe a second case bearer spray. We try to put one on from the first leaf unfolding. We put one on a couple weeks later, and then about 2 weeks later is whenever our case bearer spray goes on. So we try to get them on as early as possible. That way you're spraying it on that tree as it's actively growing, because that's when you need the most phosphorus or zinc on the trees, is on those young developing leaves to get those larger. And so they're photosynthesizing more. If you've got young non-bearing trees, make sure you back that off to about 1 to 2 pounds per 100 gallons of zinc sulfate. If you get it too strong, you can see some burn on, especially on young trees. So you want to make sure that you're not causing a burn on the young leaves and causing other problems besides the zinc deficiency. Here's a photo of what that zinc deficiency would look like, just real pale yellow leaves that's really wrinkled up. So you can see this out in the orchard, usually after a rainfall where you get a flush of new growth, and they're just a lot paler. This is a zinc deficiency, and if you're seeing this late in the season, or really like in May or June, you might even put on another application if you're getting these secondary growth flushes after rain events. If you have severe zinc deficiency, you'll see a tree like this. This is about a 25-year-old tree that's only about 8 foot tall, and it's suffering from severe zinc deficiency. And you can actually tell on the top of the tree, you see a lot of terminal dieback. So zinc can kill the tops of the trees, and this tree will be stunted for the rest of its life because of the way it's been managed, and will struggle on production until you start spraying them. There is another nutrient that we have started to see in some orchards through the leaf samples, and this is nickel. Typically, we see this in Georgia or in the Southeast, but I have noticed on the leaf samples some problems in Oklahoma being low. We usually see this with young container trees, and usually this once they're planted in the soils, there's enough nickel in the soils to take care of it. But if you see this kind of problem, like this picture on the right-hand side, those mouse-eared leaves, really small leaves, you might have to apply some nickel into your sprays to help take care of this problem. So most important takeaway from today is to make sure you take your leaf samples. And again, we'll show you how to do this later in one of the later webinars. But make sure you take those leaf samples, and that will help you determine how to fertilize the trees the following year. So a couple questions that we had, thinking about the ice storm. Do you still want to fertilize like you normally do after an ice storm? And typically I like to look at how much of the tree was damaged. And so if I've got, 40–50% of the tree that is damaged, I want to go ahead and cut back my fertilizer application, because that tree again stored up that nitrogen in its tissues. And so whenever it starts to break bud, all that nitrogen is available. So if you apply more, it's going to shoot off a lot more growth. And you can actually get too long a growth and cause problems, a couple years down the road. So I always like to back off on my fertilizers after an ice storm to make sure I'm not getting too much growth on the trees. And that way that growth is going to be stronger and can support a crop in a couple years whenever it puts it back on. Another question we had was that they had heard that applying fertilizer too late was bad because you're stimulating growth. And that is true on young trees, but typically on mature trees, you don't see a late growth because that tree's already starting to shut down, and it's really focusing on nut production. And so I don't have too much of a concern putting on fertilizer too late in the season. You're not going to see that chance of that extra growth occurring unless the crop's really light, or if I'm in a situation where I'm getting a lot of rainfall in the fall. Typically that's where we'd see secondary growth flush late in the season. We appreciate you guys attending, and if you have any other questions, please let me know.
Thank you, Charles. That was great information. If you have more questions, you can take a look at our fact sheet, HLA 6232, our fertilizing pecan and fruit trees. It has great information on soil tests, on leaf sampling, and then fertilizing young trees, and then by size instead of by leaf analysis recommendations. Our next speaker is going to be Dr. John Long. He is a professor and our extension specialist in our biosystems and ag engineering department. And he's going to be talking about sprayer calibration.
So my name is John Long. I'm an extension ag engineer in the Department of Biosystems and Agricultural Engineering. And what I wanted to talk with you today a little bit about is sprayer calibration. We're going to cover a couple different types of sprayer calibration. But before we get into that, I always like to start my talks when I talk about spray equipment in general with this application triangle. And the triangle we have on top, supported by two smaller triangles, is called productivity. And that's kind of our ability to get things done that we need to get done. So the idea is that if we have so many acres to cover, we have only a short window to get that done. And so we need to be able to be effective in our application of our chemicals and fertilizers and things that we're applying with our spray rigs. But to be able to do that, we need to make sure that we're supporting it with those lower two triangles, and that is efficacy and off-target protection, which kind of go hand in hand. Efficacy means we're actually doing a good job of coverage. We're doing a good job of actually killing the pest or applying the chemical that we need. And so if we're doing a poor job, it doesn't matter how fast we're getting it done, it's not going to be very helpful. The same thing with off-target protection. We want to make sure that we're not actually wasting a lot of chemical, spraying it elsewhere, blowing it, across the tree canopy into another outlying field or area, and making sure that we're aware of those environmental impacts, but also those pocketbook impacts where we're, using more chemistry than we really need. And so we're wasting a lot of it. So what's really the point of sprayer calibration? I know sometimes it's kind of a little bit of a dirty word and that it's something extra to do. There's so many things already to do. And so sprayer calibration is something that we need to do. And why do we need to do that? Well, big thing is it lets us dial in the amount of liquid we are going to be applying. So we might be looking at things like gallons per acre or gallons per minute. And knowing how many gallons per acre our sprayer is applying at, or how many gallons per minute our nozzles are putting out, are going to be important for us to be able to determine the number of acres, the amount of area that we're covering for the liquid we have in the tank, because we can mix the active ingredients in that tank at different ratios. And so really it's the main idea is once we know that GPA, we can then figure out how much chemical do we really need to put in that tank. So if we look on our label, it might say something like so many pounds per acre or pints or ounces or whatever happens to be the chemistry. But we want to be able to take that unit on the label and convert it into how many actual ounces of that liquid, chemical do we need to actually dump in the tank to make sure that we're putting the right rate on there. And so if we need to have 51 ounces or, 20 pounds, whatever it may be, we need to know that. And so calibration helps us figure that out. And then it also gives us the opportunity while we're calibrating to kind of look over the sprayer, especially if it's something we're doing at the very beginning of the season. We can make sure there isn't anything that happened. We had all those really low temperatures back here earlier this year. And so that could be an opportunity to make sure valves and pumps and hoses didn't have a little bit of water still in them and maybe freeze cracks or other things of issues. So it lets us check checks things that are maybe aging, so we can look all over our kind of components as we go. And then hopefully maybe the calibration, just being a regular calibrator, helps us save a little bit of money. It makes it where, we can make sure we're not over applying and wasting a lot of money putting out more than we need to, or even on the other end of things, we're putting out too little, we're not getting a good effective application, then maybe we're getting damage or issues from not doing a good job. And so that can cut into our bottom line also. So the first type of calibration we'll talk about is boom sprayer calibration. So boom sprayer calibration has kind of two ways we can look at it. We can do what I call the calculation method, where we are going to basically know what ground speed or how fast we want to drive our spray rig. And we're going to just use this method as a way to figure out what size nozzle do we need to put on there. And we use the gallons per minute equals miles per hour times our rate of water application or solution application, which is gallons per acre from the label, and our width of our spray nozzle. So that's basically the width that one nozzle has to apply. So for a boom, like a broadcast boom, like you see in the picture here, it's going to be the spacing between the nozzles. So it might be something like 15 inches, 20 inches, 30 inches, 40 inches, those types of things. And so we would get a number out, 0.3 of a gallon per minute, let's say. And so we could go to a manufacturer, go to the store and say, hey, we need a nozzle that's going to give us that at a particular pressure. So it works well for that. The timing method is the method that's a little bit simpler. And this is the one I think is the best to use whenever you're going out there to bring your maybe sprayer out from the winter and do that first application, or maybe you're adjusting the rates between different types of chemistries. And so this is really kind of a nice little shortcut. We don't have to do any big math on this one. And we just need to know exactly where we're going to go. We need to know how fast we're going. So we need to set a gear and throttle for using a tractor, for example. And we're going to already have our nozzles on our spray rig. We're just going to figure out what they're actually putting out. So I'm going to go over that one. We're going to look at a sprayer that has a nozzle already installed. The one I'm going to use here is this TTI 11004, which is a newer nozzle that's used for some of the systemic herbicides and things that you might see out there. We're going to have our gear and throttle position for our particular vehicles, so our tractor we're using. We're going to go measure our nozzle spacing. We're not going to use our nozzle spacing in the calculation of any kind of math here, but we need to know our nozzle spacing for a broadcast applicator here so that we can actually go and find our calibration distance. So the next step is determine our calibration distance. So this is distance we're going to be actually driving and timing. That's where the timing method comes from. So if I go to the chart here, and this chart is available a lot of different places. You can contact your county educator if you want an access to this particular chart. We have it in some of the fact sheets that are available out there for OSU. But the idea here is that we have a particular timing value that we need to come up with. So we use that spacing that we measure between nozzles. And I told you things like 15, 20, 30. So 20 is a pretty common one. And so say we measure 20 inches between adjacent nozzles on the boom. We go over here and we find our calibration distance in feet of 204 feet. Now, the right-hand side of this chart is an area that tells you for that calibration distance, this is the time it would take for certain miles per hour. So if you're curious on how fast you're actually driving, say if you're driving 4 miles an hour, then it's going to take you about 34, 35 seconds to actually travel that 204 feet. And that comes down from this equation to know the math in behind this, where we have 88 feet in 1 minute is a mile per hour. So if we travel 88 feet over a minute, that's 1 mile per hour. So you can look at that and take your time in seconds and your distance in feet and calculate miles per hour. But the big thing here is we want to measure nozzle spacing and figure out a calibration distance. So 204 here. So then after we've measured that calibration distance, we're going to basically lay that out in an area similar to where we're going to be spraying. And then we're going to actually fill up our sprayer and we're going to drive that distance. So mark 2 flags, 204 feet apart. We're going to drive that distance and we're going to get our stopwatch out and we're going to actually time ourselves. So if we mark out that 204 feet and I drive it with my spray rig, and I end up with 34.8 seconds elapsed on the stopwatch from starting flag to ending flag. That's going to tell me that's going to be roughly, like we looked at before, about 4 miles an hour. But the big thing here is it doesn't matter what your speed is if you don't know it, as long as you can time that distance. So 34.8 seconds is what we're looking for. The only caveat I want to say here is if it gets really short, say you're going a lot faster, which is probably not going to be happening unless you're in like a self-propelled sprayer or something like that. If your time gets less than 20 seconds, then we need to double that time, because what we're going to do is after we've collected that time it took to drive between those 2 points, we're going to catch water out of each of our nozzles using that time. So I'm going to go to the first nozzle on the boom. I'm going to put my collection cup underneath it, and I'm going to turn the pump on, and I'm going to spray water into that collection cup, and I'm going to use my stopwatch, and I'm going to collect water exactly for 34.8 seconds. So I'm going to have the sprayer going, and then I'm going to capture water underneath it, and then I'm going to pull my cup away from it. And essentially what's happening here is because of that 204 number we pulled out of that chart, every ounce we capture during that time period is going to equal 1 gallon per acre rate. So if we catch 30 ounces, for example, for that 34 seconds, then we're putting out 30 gallons per acre, which might be a whole lot for what we're doing. It might be too little for another type of application. So if we're shooting for 10 gallons per acre, then we're putting out way too much. And so we need to make adjustments to take care of that. So we take that distance that we measure, that time it took to traverse that 204 feet for a 20-inch nozzle spacing, we go capture, and we do that. Now, you can capture from one nozzle. Since they're all the same nozzles, we should get the same amount. But this is an opportunity to go actually catch from each nozzle and make sure all the nozzles are putting out the same. If you got one that's putting out more, that means that nozzle is worn, and there's a good chance that you should probably be changing that. Now, the rule of thumb we use is about 10%. So if you were looking at a nozzle, all the other nozzles are putting out 30 ounces, let's say, and one nozzle is putting out 33 ounces, that one there is worn and we probably should be changing it out. So what if it's not what you want it to be? The label says we need to be 10 gallons per acre. I'm putting out 30. Well, that means that our measurement was too high. And so we need to dial back our pressure or increase our ground speed, or then go back and choose a whole different nozzle that's smaller. Opposite, if the measurement we measured was say 5 gallons per acre and we need 10, then we need to either increase our pressure, decrease our ground speed, or pick a larger nozzle. Now, the big thing with this timing method is, since we're not actually looking at a chart, it's important that we don't get outside the nozzle's range. So every nozzle is going to have a particular pressure range. If we just use pressure as our way to make adjustments, we need to be very careful about that. And typically the rule of thumb I look at is if we have to double our rate, our gallons per acre, then we should probably not play with pressure. We should probably play with ground speed or go and change out our nozzle. Ground speed will be the easier one if you don't want to have to buy a new nozzle. But sometimes ground speed is going to get too fast for us also. So we need to be careful with that. So double the rate change. We want to look at a different nozzle or a different ground speed. So what about handheld sprayers? We use handheld sprayers for lots of different things also. The way we do that, we can use the timing method for it too, where we don't have to do the math. The key here is 340 square feet. So if you remember 340, just a little bit short of 360. So 10 foot by 34 foot area. So you lay out an area that's 340 square feet. Now you can make that shape however you want to make that shape, but lay out an area that's 340 square feet. Then we basically take our sprayer and we go through and we time ourselves spraying that area with a hand wand. And so the amount of seconds it takes us to spray 340 square feet, we're going to go then refill our sprayer. We're going to put that spray nozzle into a catch container, and then we're going to press that handle and spray that into that catch container for that same amount of time. So if it took us 30 seconds to spray that 340 square feet, we're going to spray into a container for 30 seconds. And then again, the number of ounces we capture equals our gallons per acre rate. So to make sure we're on the labeled rate. Now, if you're dealing with a hand wand that has a lot of pressure or uses a really, say, large region, we're trying to spray up in trees or something like that, we may not be able to just spray it directly into a container. We may want to have a garbage bag or something like that we can completely wrap around the end of the wand and open it up. That way we're not getting backsplash in us and things like that. So be careful when you're spraying into a container with a wand that is under a lot of pressure. So what about air blast sprayers? Air blast sprayers can come in a couple different types. We can have the single direction like we see a lot in pecan orchards, or we can have the big radial fan style like in this peach orchard, I think there on the screen. The way we're going to do this to calibrate air blast sprayers, we're going to use a sort of a calculation method, and we're going to just calculate how much our GPA is and then determine whether we want to change it or not. And the way we calculate that is we're going to first pick our ground speed. The easiest way nowadays is GPS. A lot of people have smartphones where you can find an app for speed. If not, if there's not a speedometer or something on the vehicle that you're using for your sprayer, then we can use the timing method. If we go back to that chart I previously showed you, and remember that 88 feet in 1 minute is 1 mile per hour, then we're going to have, in this case, if we're doing 2 miles an hour for our example, then we're going to be doing 176 feet in a minute. So that tells you your ground speed. So 2 miles an hour is what we're going to be shooting for. So let's say we're going to apply some type of fungicide, and the label says making sure you have sufficient basically solution to apply full coverage. So we're going to pick a nice round number like 100 GPA for our air blast sprayer. So we've got our speed and we've got our rate of our carrier volume, our solution that we're trying to spray out of our sprayer. And so now we want to actually take and figure out what our flow rate is for each side of our sprayer. So we calculate what the flow rate should be in gallons per minute for each side, if we're talking about single-sided or fan style, radial style. And then we go through and actually measure what we're actually putting out in gallons per minute. And then we adjust that on our sprayer. So it's where it's kind of a little bit of a calculation and an adjust type of thing here versus like a broadcast herbicide sprayer. So this is the equation that we're concerned about. It looks very similar to that calculation method for the broadcast one, except for our conversion factor here is 990 instead of that 5940. But we have miles per hour times our rate that we're looking at times our row spacing. So here we're now not looking at the actual nozzle spacing or anything on the spray rig. We're looking at what is the row spacing of the trees. So if this is for a single-sided sprayer, if we're going to spray both sides at the same time, so we're going to spray one side of one row and another side of another row at the same time in a single pass, then 495 is going to be a conversion factor. So we'll remove 990 from this equation and plug in 495. So in our example, we said we were going to be traveling with our sprayer at 2 miles an hour. We were targeting from our label 100 gallons per acre, and say we're only going to be on, say, a 60 by 60 grid planting for our orchard. So our rows are going to be 60 feet apart. And then 990 is our conversion factor. So if I plug all this in my calculator, 2 times 100 times 60 divided by 990, I get 12.1 gallons per minute. So this is for a single-sided. So if we're looking at a traditional single one side of the tree pass, then we're going to be putting out at least 12 gallons per minute out of that. So that's our target to get 100 GPA. We're going to be looking for to make sure our sprayer puts out at least 12 gallons per minute. So now we actually measure it. So we measure our sprayer and figure out what it's actually putting out. So the way we do that is we fill our sprayer up with water. We put it on a nice level surface, and then we turn that sprayer on and let it spray just plain water for at least 5 minutes. And then we have 2 ways we can figure out how much we actually applied in that 5 minutes. We either measure the amount of water it takes to refill the tank. So the way we would do that is we'd fill our tank up and maybe mark a line or have a set place on the tank where there's maybe markings for gallons, and have that as kind of our point, mark that, let it spray for 5 minutes, and then refill the tank back to that line. So don't necessarily use those tank markings unless you know they're really good and you've got markings that are accurate. Sometimes those molded in markings are not always super accurate. So the way you can do that is just basically measure your water before you dump it in the tank. It takes a little bit longer that way, but you can see how much actual water you sprayed out. The other way you can do it is you can actually put a hose, and this is an example here in the picture I've got, is you can take this hose and rig it up and basically hook it on each of the nozzles and turn them on and run each one of these hoses into a catch container. And we measure then the amount of water we actually put out that way. So if we're looking at 12.1 gallons per minute was our target, and if we run that for 5 minutes, then we should be getting about 60.5 gallons out of the entire side. So if we have 10 nozzles, we're going to be getting 60.5 gallons out of all 10 nozzles. And so then we compare that. Did we get 50 gallons? Did we get 80 gallons? What do we get? And that'll tell us how close we are to what we should be. So just like before with the timing method, if we captured way too low, so we were supposed to get 60, we only caught 40, we need to increase the pressure to our fluid. We may maybe even change our ground speed, which means recalculating things, or we might need to change our nozzles out. Hopefully not, but that's something that we might have to do if we have to really adjust the rate. The other way around is if we caught too high, so we caught 80 gallons and we should have been catching only 60, then we might need to back our pressure back, increase our ground speed, or choose a smaller nozzle. And then the third option for a air blast sprayer is, where we don't have a set rate that the label gives us, just says sufficient coverage. There's a possibility that we just live with what we have. So if the GPA is not super crazy off, maybe we are okay with it as long as we're getting good coverage, and that's a whole nother topic of discussion. But for example here, say we're going to be applying a fungicide here like Super 10, Agri 10, one of those at a rate of 12 ounces per acre. And our perfect calibrated sprayer, our 500-gallon sprayer, has a perfect calibration of 100 gallons per acre. So we've calibrated perfectly, we've got dialed in with the pressure. So we know that for that 500-gallon tank, if we divide it by our GPA, we get 5 acres. So it's going to take 100 gallons for each acre. If we've got 500 gallons to give, then we're only going to be able to cover 5 acres in a single tank. So we know we're supposed to put 12 ounces per acre. So 5 acres times 12 ounces per acre gives us 60 ounces that we need to dump in that tank to cover that 5 acres. So that'll give us that perfect rate that we're looking for on the label of 12 ounces per acre. Let's say we measure our sprayer and we're only putting out 80. Well, first we need to make sure 80 is good enough for coverage. If it is, then we can maybe just live with 80. It's not a nice round number like 100, in that when we divide it by our tank volume, we get 6 1/4 acres, which is, not a whole acre. We've got partial acres here. Multiply that times our 12 ounces per acre, we get 75 ounces in each tank. So this worked out nice and even because of the numbers I chose, but it could be that our rate is a number that gives us a partial ounce. So we just have to be careful in that when we actually measure it. But these both are going to give us the correct rate of 12 ounces per acre. We're just going to have a little less water in this volume than this one. So that's something to be aware of and make sure that's acceptable. If you're getting good coverage with that, then the big thing here with calibration is knowing exactly what your rate that your applicator is putting out. Other considerations, coverage, like I said, is something we can talk about and completely whole nother topic, but making sure you're getting good coverage with your sprayer whenever you're applying. So that might mean increasing your rate in gallons per acre if you are actually not getting good coverage with what you're currently doing. The other thing is the droplet size. Smaller droplets are going to have a harder time moving. They're going to be caught in the airstream, but sometimes those droplets are going to have a lot harder time getting into the canopy. They're also going to be ones that are going to take a lot longer to actually settle and fall out of the air, so they could cause drift issues. The rule of thumb for nozzles, if you have to actually change nozzles, is that the upper half set of nozzles, so this has got 10 nozzles on it, so the upper 5, we want to have whatever our rate was. So in our example, it was like 12 gallons per minute. We want to have at least 2/3 to 3/4 of our rate coming out of these top 5 nozzles versus the lower 5. And the reason for that is, you think about it and looking at this picture here, this lower nozzle, as it throws a droplet, think of the droplet as being kind of more like a tennis ball or something like that. If I throw that thing on an arc, if my arc's really low and I don't hit my target, so I don't actually hit this lower leaves, then I'm going to fall short and it's get caught and drift down and fall down onto the floor. And that's not really going to help us because that chemical didn't get to where it needed to be. So having most of the flow up here on the top means that if it happens to maybe fall short of hitting the top of that tree, at least it's going to hit somewhere in the canopy and be effective for us versus being on the ground. And one of the ways we can do that is there are new nozzle technologies out there versus the standard disc and core style setups that you see on a lot of sprayers, especially older air blast sprayers. There are now new air induction ones that flow the same amount of fluid rate-wise, GPM, but they produce bigger droplets. So we think about a ping pong versus a tennis ball. This tennis ball is going to probably make it to that target a lot quicker and easier than this ping pong because there's things like air resistance and other stuff that's going to push it off course. So having those bigger droplets will help out with that too. So with that, I will wrap up and be happy to answer any questions. Feel free to contact me with my information here below. And thank you for your time today.
That was really great information on sprayer calibration. We also have some other information on the Pecan management webpage. You can find one, a calibration information sheet. Dr. Mike Smith, who's retired, and Dr. Phil Mulder put together a little informational sheet that's available on our Pecan webpage at okpecans.okstate.edu, or you can get in touch with Dr. Long for more information if you need him as well. I wanted to thank everyone for tuning in this month, and encourage you to join in on our April 9th Zoom meeting when we will be talking about getting started with grafting. We'll have someone talk about some early disease management that we may need to be looking at. We'll probably be talking about weed control, and then I'm sure Dr. Phil will join us for an update on insect pests and any other thing that may be happening that we need to be discussing at that time. Be sure and register for the OPGA annual meeting, June 10th through the 12th, and be watching for other events that are may be held across the state. And thanks for tuning in. We'll talk to you later.